In this video, you will see how to build a binary classification model for a marketing campaign with Watson Machine Learning in IBM Cloud Pak for data. This video uses a bank marketing dataset that was already added to a Watson Studio project. Viewing the dataset, you'll see that the data contains customer information related to a direct marketing campaign for a bank. The classification goal is to predict if the client will subscribe to a term deposit. Go back to the Assets tab and add to the project an AutoAI Experiment. Just provide a name for the experiment and then click Create. Next, the AutoAI Experiment Builder displays. You first need to load the training data. In this case, the dataset will be from the project. Select the Bank Marketing CSV file from the list. AutoAI reads the dataset and lists the columns found in the dataset. Since you want the model to predict the likelihood that a customer will subscribe to a term deposit, select Y as the column to predict. Now edit the experiment settings. First, look at settings for the data source. If you have a large dataset, you can run the experiment on a subsample of rows. And you can configure how much of the data will be used for training and how much will be used for evaluation. The default is a 90% 10% split, where 10% of the data is reserved for evaluation. You can also select which columns from the dataset to include when running the experiment. On the prediction panel, you can select a prediction type. In this case, AutoAI analyzed the data and determined that the Y column contains yes/no information, making this data suitable for a binary classification model. The positive class is yes, and the recommended metric is accuracy. If you'd like, you can choose specific algorithms to consider for this experiment, and the number of top algorithms for AutoAI to test, which determines the number of pipelines generated. On the Runtime panel, you can review other details about the experiment. In this case, accepting the default settings makes the most sense. Now run the experiment and wait as the pipeline leaderboard fills in. Next, AutoAI generates pipelines using different estimators, such as the XGBoost classifier, or enhancements, such as hyperparameter optimization and feature engineering, with the pipelines ranked based on the accuracy metric. Hyperparameter optimization is a mechanism for automatically exploring a search space of potential hyperparameters, building a series of models and comparing the models using metrics of interest. Feature engineering attempts to transform the raw data into the combination of features that best represents the problem to achieve the most accurate prediction. Okay, the run has completed. The legend explains where to find the data, top algorithm, pipelines, and feature transformers on the relationship map. You can view the full log to see complete details. By default, you'll see the relationship map, but you can swap views to see the progress map. Scroll down to take a look at the leaderboard. You may want to start with comparing the pipelines. This chart provides metrics for the 8 pipelines viewed by cross-validation score or by holdout score. You can see the pipelines ranked based on other metrics, such as average precision. Back on the Experiment Summary tab, expand a pipeline to view the model evaluation measures and ROC curve. During AutoAI training, your dataset is split into 2 parts: training data and holdout data. The training data is used by the AutoAI training stages to generate the model pipelines, and cross-validation scores are used to rank them. After training, The holdout data is used for the resulting pipeline, model evaluation and computation of performance information, such as ROC curves and confusion matrices. You can view an individual pipeline to see more details, in addition to the confusion matrix, precision recall curve, model information, feature transformations, and feature importance. This pipeline had the highest ranking, so you can save this as a machine learning model. Just accept the defaults and save the model. Now that you've trained the model, you're ready to view the model and deploy it. The Overview tab shows a model summary and the input schema. To deploy the model, you'll need to promote it to a deployment space. Since this project doesn't have a deployment space associated with it yet, you'll need to set up the association first. You can either create a new deployment space or select an existing deployment space. Back on the model overview, promote this model to a deployment space, and then go to the deployment space. Here's the model you just created, which you can now deploy. In this case, it will be an online deployment. Just provide a name for the deployment and click Create. Then wait while the model is deployed. When the model deployment is complete, view the deployment. On the AP Reference tab, you'll find the scoring endpoint for future reference. You'll also find code snippets for various programming languages to utilize this deployment from your application. On the Test tab, you can test the model prediction. You can either enter test input data or paste JSON input data and click Predict. This shows that there's a very high probability that the first person will not subscribe to a term deposit, and a high probability that the second person will subscribe to a term deposit. And back in the project on the Assets tab, you'll find the AutoAI Experiment and the model. Find more videos in the IBM Cloud Pak for Data Learning Center.